This is a Geiger counter made using components from the vintage Radionic electronics construction system. It's powered by a 12-volt battery and includes no integrated circuits. These two transistors form the basis of an oscillator which runs at around 50 Hz. The oscillator drives a 9-volt mains transformer in reverse, so the voltage is stepped up rather than stepped down as normal. The output from the mains transformer is then both rectified and doubled by these two diodes and these two capacitors. And then that output, high voltage DC, is regulated down to 400 volts by a string of 3 zener diodes and 2 neon bulbs. 400 volts is applied to the Geiger-Muller tube. When radiation causes ionisation inside the Geiger-Muller tube, an electron avalanche generates a pulse, which is amplified by this transistor and then used to trigger a 2-transistor monostable. Once the pulse comes out of the monostable, it's a square wave pulse of fixed width, and that pulse is used to charge this capacitor, which is simultaneously being discharged by this resistor through this meter. The component values are chosen so that the meter reading corresponds to the average counts per minute over the recent past, over around 10 seconds. Okay, let's switch on. So what we can hear now is the background radiation. It's typically around 20 to 30 counts per minute here. And it's coming from radon gas in the air. It's coming up from the earth below and also from cosmic rays from outer space. My first radioactive sample is actually available in the supermarket. It's salt substitute and it uses potassium chloride instead of sodium chloride. So we're at about 20 counts per minute now, and let's see what happens when we introduce a bag of low sodium salt. See, it's rising. Most potassium atoms are potassium-39, a stable isotope, but around 1 in 10,000 of them are potassium-40, an unstable radioactive isotope. And that's why this low sodium salt is very slightly radioactive. So we're reading around 50 counts per minute now. Might even get to 60. These are tungsten inert gas TIG welding rods and their 2% thorium oxide. Thorium is added to the tungsten to increase the current carrying capacity of the electrode. Thorium is a radioactive metal with an atomic number of 90, and any element with an atomic number greater than 83 is radioactive. This is a gas lamp mantle used to produce light. When the mantle is heated by the burning gas, the thorium emits an incandescent glow. The thorium is added by dipping the mantle in a solution of thorium nitrate. The mantle is radioactive due to the thorium content. The next three samples all contain uranium. This is a sample of a uranium ore called Uraninite or Pitchblende. It's what's extracted by most uranium mines. It's mainly composed of uranium dioxide. This is a uranium glass bead. Uranium glasses have an oxide of uranium added to the glass mix before melting to add colour. These are fragments of Fiestaware, a range of dinnerware made in the US. Orange Fiestaware has uranium oxide in its glaze to produce an orange-red colour. Fiestaware made from 1936 to 1972 may be radioactive. So we need to change the range of the meter because it's going off scale. What I can do is change this to times 10, and now instead of reading from 0 to 100, the meter's reading from 0 to 1000 counts per minute. And we can still run the meter off the scale if we get close enough.